Okay, folks, welcome in, and we're going to take a look at section 6.2. We are going to use the calculator technology to answer these questions. So it says we have a recent poll found 55% of adults in a certain country believe the overall state of moral values is poor. And then we take a random sample of 40 adults. And part A says, what is the probability that exactly 20 of those surveyed feel the state of moral values is poor? Okay, so this is essentially a binomial distribution, and we have n equals to 40, the number of trials, and p, the probability of getting someone that claims the overall state of moral values is poor is 55%. So we can essentially treat that as the probability of success, because the binomial distribution does not care what we call a success. So let's go ahead and let's figure out the probability of exactly 20. So we're going to go over to our calculator, and we're going to go to the binomial distribution, and we're going to arrow up to binomial PDF. The number of trials is 40. P is 0.55. And we want to know the probability of getting exactly 20. So let's see. Okay, 1025. Okay, and then in 100 trials, we would expect about 10. Okay, no more than 20. So here we're looking at the probability that x is less than or equal to 20. So no more than 20, we can say no more than 20. X is less than or equal to 20 is another way of saying no more than 20. So this time we want to use the probability that x is less than or equal to 20, which is the binomial CDF. N, number of trials, P, probability of success, and X is 20. So distribution, binomial CDF, and 40.55, 20, so we get 3156. Okay, and then here we'll expect about 32. Okay, find and interpret the probability that more than 21. So more than 21 means 22 or more. So let's look at this. More than 21. X is more than 21, which can be written X is greater than or equal to 22. So we're really counting 22 all the way up to 40. And we can say that the total probability from 0 to 40 is 1. So essentially what we're going to do here, let me just write it out. 0, 1, 2, 20, 21, 22, all the way up to 40. So we're looking for greater than or equal to 22, which is all that probability. So we're going to remember the total probability is 1 from 0 to 40. So we can say that this is equal to 1 minus the probability that x is less than or equal to 21. Okay, so let's use the CDF. We're going to go from 0 to 21, and we're going to take 1 minus that. So 1 minus CDF and 21. Let's double check that. Yeah, 21. Okay, so we get 5651. Okay, and we would expect about 57. Okay, 19 or 20, so we're going back to probability of x equals to 19 or 20, which is PDF. PDF, remember, gives us exactly. So we'll do PDF. .55, 19, and then we'll add that to PDF evaluated at 20. Paste and enter. So we get 1824. And this will be about 18. Okay, so find the probability. Would it be unusual to find 28 or more? So we want to find the probability of getting 28 or more. And so that's going to be 1 minus the probability from 0 to 27. So 1 minus CDF .55, and then x, the upper bound, is 27. Okay, so 1 minus the probability from 0 up to 27, which is the upper bound for the CDF, gives us the other probability, 28, all the way to 40, and that's what we want. So 0386. 0386. Would it be unusual? Yes, anything less than 5%. So yes, it would be unusual because the probability of 28 or more, believing the overall state of moral values is poor, is very high. No, it's not very high because the probability of 28 or more adults believing the overall state of moral values is poor is very low. That's what we want. Okay, fantastic. I hope this helps with the technology part.